Hi everyone, this is Dr. Arthy, associated with Kamaraj College of Engineering Technology as an associate professor in the Department of Information Technology. In this video, we are going to look into one specific algorithm which is present in minimum spanning tree, that is none other than Prim's algorithm. In the previous video, we were covering about what is spanning tree and why it is called as minimum spanning tree, and we were discussing in detail about Kruskal algorithm. So, in this video, we will be discussing about one other algorithm which is called as Prim's algorithm. Comparing the Prim's algorithm with Kruskal, as we said with Kruskal algorithm, that specific algorithm works with edges. That is, an edge table will be framed, and based upon the weight of each and every edge, it is sorted, and then based upon the visiting process, the entire spanning tree is constructed. So, this is how the Kruskal algorithm works. Whereas in the case of Prim's algorithm, we are going to consider node by node, vertex by vertex, and thereby the spanning tree will be constructed having with minimum cost. So, now let us explore this algorithm having with an example. Let us consider the graph which is having nearly 6 nodes, and each and every nodes are connected having with some weight. So, this is a weighted undirected graph. Having with Prims, we are supposed to mark the starting node of any specific graph. So, let us take the node A as a starting node. As I said, we are going to traverse vertex by vertex, and we are going to see whether the vertex can be visited through that edge. One thing that has to be kept in our mind is we are going to construct a spanning tree. A spanning tree is nothing but a tree which is formed from a graph with no cycles. So, that is what called as spanning tree. So, we are going to take that into a base constraint. So, hence, when we are traversing the graph having with the vertex, we are going to see whether the edge can be marked such that there is no cycle, right. So, let us see how this can be constructed. Starting with the node A. Now, the node A is the starting node. So, let me mark the node A as a starting node. Having with this node, now we are going to find what are the possible edges that reaches the other nodes, that is the outgoing edges of A. The outgoing edges of A are to B, to E and to F. Now, we are going to consider the minimum cost spanning tree. So, we are going to have the 3 possibility of A, whereas from A to reach B it is 1, from A to reach E is 2, from A to reach F is 4. Out of these 4 outgoing edges, 1 is the shortest edge. So, from A we are going to reach B, which is having the shortest edge as 1. Now, the node A is visited. So, we have visited the node A. Now, we are going to visit node B, that is from node B, what are the nodes that can be reached. So, let me change the scenario of this to B. So, from B. So, from B we have 3 different outgoing edges, 1 to C, 1 to A, 1 to F. A which is already visited, so we are not going to consider that. And we have C and F. So, C and F. To reach C it takes the cost of 1, and to reach E it takes cost of 3. So, out of these 2 edges, the edge from B to C is having the minimum cost. So, we are going to reach the node C from B, which is having the minimum cost as 1. Now, the node B is visited. Now, we are going to visit node C. Having from node C, there are 3 outgoing edges, 1 to B, the other one to E, the other one to D. B which is already visited, so we are not going to consider that. Looking into E, so it takes cost of 2, and having with D, it takes cost of 5. So, out of these 2 edges, the edge between C and E has minimum cost. So, we are going to construct an edge from C to E which has the cost as 2. Now, the node C is visited. Now, having from node E has nearly 4 outgoing edges. So, it has 4 outgoing edges, 1 to A, the other one to B, the other one to C, the other one to D. So, A and B, all those nodes are visited. So, we are not going to see that, because if you are going to have any edges between A to E or B to E, now what happens? This will become a closed loop. So, this will lead to cycle which is violating the rule of spanning tree. So, that is the reason why we are not looking into the already visited node. So, A and B are already visited. Now, looking into C. So, C is again it is a bidirectional flow, right. So, C is also already visited. So, having with D, this is having the cast of 3, right. So, it is having cast of 3. So, from E we are going to reach D having cast of 3. Why we are not considering B? B is already visited, and if I am going to have a path between E and D, see this is having cast as 3 whereas B is having cast as 2. We could think that from E to A it is cast as 2. We would think that 2 is the minimum cast. So, let me construct a edge between A and E. Now, what happens if I am going to construct a path between A and E? This will lead to a closed loop, right. So, this will violate the principle of spanning tree, and that is the reason why we are not considering the visited nodes. So, already visited nodes are omitted. So, even though comparing to 2, 3 is high cast, 3 is considered as A is already visited. So, D is explored now. So, we have visited E. Now, from D, so we are going to see what are the nodes that can be reached from D. So, from D, C, E and F. So, all these 3 nodes are reachable, and D to E is bidirectional flow, we are not going to consider, and C we have already visited. So, if I am going to mark a path between C and D, this will become a closed loop. So, we are going to omit this visited node also. So, the one and only node that is left out here is F. So, from D we are going to have F, which is having cast as 1. Now, we have visited D. The left out node is F. So, looking into the node F, all other nodes in the graph has been visited. So, ultimately there will be no other node to explore further. So, we can stop our process when we have only one node that is left out in our travelling process, right. So, having with this specific graph, we have obtained that this specific tree is what? The minimum spanning tree. So, calculating the total cost of this specific tree will be 1 plus 1 plus 2 plus 3 plus 1. So, it is 5, 6, 7, 8. So, 8 is what the minimum spanning tree cost, fine. So, this is how Prim's algorithm works. So, we are taking a node by node processing is being done, and this process can be solved having with the adjacency matrix. So, let me show the same set of process using adjacency matrix. Here we have not considered the adjacency matrix, instead we have taken our traditional way of looking into whether the node is having incoming edge or outgoing edge. So, based upon that we solved now. Let me take a same problem having with the adjacency matrix. So, to construct this adjacency matrix, we know we will be taking the vertex, whatever vertex that we have, we will be taking the vertex like A, B, let me write it somewhat further, like A, B, C, D, E, F. The same way A, B, C, D, E, F. So, we will be writing all the possible vertices in the row as well as column. Now, let me construct the adjacency matrix of this. This is not having a self path. So, all the self path will be having no values, right. From A to B it is 1, from A to E it is 2, and A to F it is 4, right. So, this is how we will fill the adjacency matrix. So, we will be looking into the outgoing edges of each and every node. Similarly, from B to A it is 1, B to C it is 1, B to E it is 3, and for remaining it is not having any value. And from C, B, E, D are reachable node having with the cost as 1, to D it is 5, to E it is 2. And from D we have 3 possible paths. One is to C with cast as 5, then to E it is cast as 3, and then we do have to F as 1. Fine. And from E we have 4 different edges, 1 to A as 2, to B it is 3, to C it is 2, and to D it is 3, and having with F there is no edge, and for F to A it is 4, and to D it is 1, right. So, I have constructed the adjacency matrix having with this specific graph. So, once again I will repeat, from A we have reached B having with cast as 1, to E it is 2, to F it is 4. The same way let us take for E, from E to reach A it takes cast as 2, to B it is 3, C it is 2, and D it is 3. The same way when I am taking D, from D to C it is 5, F it is 1, E it is 3. So, likewise we have constructed the adjacency matrix. Now, having with this adjacency matrix we are going to construct the spanning tree. As we said, this would be our starting node. So, let me have a tree representation of this having A as starting node. So, from A, looking into adjacency matrix, we have obtained that the node B has the shortest cast, minimum cast as 1. So, from A to B cast is 1. Now, A is explored. Now, we are going to see B. So, looking into B. So, this is what the row that represents the cast of the node B. So, having with B, as I said, 1 is already visited. So, we are not going to look into 1, and the next value will be here as C with cast as 1. So, from B we can reach C with cast as 1. Now, B is visited. Now, we are supposed to move to node C. Now, having with C, so C is having the edge with B as 1, D as 5, E as 2, but B is already visited. So, we are not going to consider this. So, we are going to take the minimum out of it, which is 2. So, 2 is nothing but C with edge having with node E. So, this is what 2. Now, we are going to explore the node E. So, coming to node E. So, this is what the line which is telling about E, where this is having the link with A, but A is already visited. It is having edge with B, B is also already visited. It is having edge with C, C is also already visited. So, now the shortest distance of this specific row will be 3, which is with respect to D. So, we are going to have the node D with having cast as 3. Now, we are going to explore the node D. Now, coming to node D, we are having the edge between C and D, but C is already visited. E and D, E is already visited. So, we are going to have the edge between D and F. So, between D and F having the value as 1. Now, D is visited. So, as I said you, we have 6 nodes, 5 node has been visited. If the n minus 1 node has been visited, we can stop the process. So, out of 6, 5 nodes has been visited. So, we can stop the process over here. So, it means that all the vertices in this specific graph has been visited. Now, computing the total cost of this specific spanning tree, 1 plus 1 plus 2 plus 3 plus 1, which is 8. The same value we have achieved in our previous way of solving also. So, looking into Prim's algorithm, we are going to take node by node. Each and every node will be taken, and we are going to see the shortest distance between the current node and the next node, and that shortest distance is being taken into consideration and it is being proceeded further. So this is how Prim's algorithm work, and that is the main difference between Kruskal algorithm and Prim's algorithm. So let me summarize the entire part of a minimum spanning tree. So spanning tree is nothing but a portion of a tree where every node will be covered without cycle. So that is what called as spanning tree. The reason why it is called as minimum spanning tree is all the nodes are covered with a short distance. So that is what it is called as minimum spanning tree. We have two algorithms, one is Kruskal algorithm, the other one is Prim's algorithm. Both algorithm works in a greedy method way, whereas Kruskal algorithm will work depending upon the edges, Prim's algorithm works depending upon the nodes. In Kruskal algorithm, every graph is represented with the edge table having with edge and its respective weight, and then it is sorted based upon the weight, and then the spanning tree is constructed. Whereas in Prim's algorithm, from the start node by node process is being considered in order to construct the spanning tree. So both algorithm will work very fine in case of finding the shortest distance covering the entire city. So if any example has been given to explore the entire place in a specific location in a specific place, in that case this algorithm will be working very fine. So that's with the minimum spanning tree, looking with the Kruskal algorithm and Prim's algorithm. Let us meet in another video with another concept. Thank you.